yeah, hi, hello. Can you hear me if my voice is audible? And then we can start. We'll be starting in just 2 minutes or 5 minutes. Uh, oh, you can hear me. I hope my voice is quite good. I started a live session today and it was not very good. So I thought let's do it in this channel. So in this channel, what we'll be doing is in this live feed, what we'll be learning is we have to connect our Delta PLC with Factory IO via KepServer. If you see on my table here, a lot of things here, you can see I have a Delta PLC, right? If you have used this PLC, you might know that this has an Ethernet connection and you can connect some input outputs, you can program it. And this is PLC, this is sponsored by Delta Electronics, right? And we will be linking this PLC with Factory IO via KepServer. So that's the PLC here, and this is linked to my computer. So when you have this PLC, if you have this PLC as well, just give it some power, 24 volts at here, and I hope it's fine here. You can see it, and then you have to connect the Ethernet port, right? When you connect the Ethernet port, you have to go to your system, and in the system you will go to Control Panel here, and you have to set the IP address. Now this Delta PLC comes with a default IP address, which is 192.168.1.5. okay, we have to link this PLC with our network card, which comes in our network settings. You will find here, probably you will find it, Network and Sharing Center, and you go to your adapter settings, and here in Ethernet you will see IP4. Here you have to put 4 if your PLC is 5. To just confirm that, I can show you my communication manager, and here I press configure. So that's my PLC IP address, 192.168.1.5, right? So that's my PLC IP address, which is in the Delta PLC. We have to link this to Factory IO. Now if you see in Factory IO, we don't have the option to link Delta PLC, which is quite, I'm not happy with it, because this is a very good software and you should be able to connect to all the PLCs. So it doesn't have a Delta PLC. I also tried with Modbus IP client, but it didn't work. So I thought, what should I do? In this case, what I can do is I can link this PLC to KepServer, and then I can link KepServer to Factory IO, which is a quite a loop thing, but we can do it. So let's try. So I will go back and I close this. This is just to show you the IP address. Okay, cancel it, close it, close it, close this. Now what I'll do is I'll open my KepServer. So this was already open. I'll close this one again, and I open KepServer. You have to install this KepServer. This software is free of cost. You can install it in your computer, and you can reset the software after every 2 hours so that you can keep using it again and again. And it doesn't matter which PLC you have, this can be linked to all the PLCs. So I will remove this Delta PLC just to show you how does it work. So when you open the software, you will see interface like that. All right, then you click to add a channel, and here you will see all the PLC brands. Right, pretty nice. But again, there is no Delta PLC here, but what you have is you have Modbus here. Modbus TCP IP Ethernet. Just click on that, click on next. Now shows the channel. Now here you can put whatever you put. I will put Delta 12SE. Okay, press next. Virtual network, no, this is by default. Okay, my default adapter is my Ethernet, so I can check this one. This is my Ethernet adapter. Press next, next, and next, and you can press finish. Okay, so your PLC is here linked. What you can do is now you will, this was the channel. Now you will add the PLC, because you have to, I can also write here Delta PLCs, because if you have so many PLCs, you can connect Delta PLCs, 5 PLCs, 10 PLCs. So now I'm adding the PLC. Before it was the channel, Modbus, and now comes my IP address. So this is 192.168.1.5. Press next, and press next, 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 next. and everything is okay. Click finish. So now the PLC is configured. So volume was low. Okay, do you have any questions? Can you do Logix 5000, Ellen Bradley? I hope I will do it one day, but today maybe not, maybe some other time. Okay, so let's see how to add a tag now. So to add the tag, it's very important for you to understand that we have configured the Modbus here, Modbus TCP IP. So we will add the Modbus addresses. Okay, so I'm going to show you the tag for bit M0. So now bit M0 has a Modbus address of 002049. This is my first bit, memory bit M0. I want to read this in KepServer. So I'll go to KepServer, add a tag, and the address. Now the address I will put from here 002049. So I will type 2049. Very nice. And this is my read write. That's okay. Scan time is okay. And to put the name, I will write DVB. Why I'm writing DVB12SC, I will tell you later. M0. But you can put any name here. I prefer this. Press OK. So this is the tag here, right? Read write tag. Now I will just click here, quick client and Delta DVP PLC. Now here I have to add the tag. Okay, so I will go to my tags which I've just made. Delta PLC, this is the tag. Click OK. So here comes the tag. Okay, and I have to just reinitialize my KepServer because sometime the trial version is over. So I click start again. Runtime loss, connect. Yes, you can save the change. I will change the settings. Delta 1 looks okay. And 002049, this was the tag. Yes, you can see the tag is green, and now let's see the status. So this is my KepServer over here. This is the value of the tag. Now I open my PLC and I put it here like this. This is very important step when you are dealing with servers, because when you work on SCADA, you generally define OPC server. So we have just defined OPC server for KepServer, right? Now I will go to my edit monitor device monitoring. Maybe this would come online edit. No, not that one. Yes, monitor table. I will write here M0, and I have to link my PLC to my software to my PLC. So what I'll do is I will go to just to check if everything is okay. You can see PLC is stop. PLC is at run mode, and this is my M0. If I set on, this M0 is set on, you can see this value goes 1 here, right? Now this value 1 is on because this bit is on. So this KepServer is reading the status of my bits. Set off, now it's 0. Okay, again I can do set on. So this is take some time, but yeah, it's 1, so it's true here. So we are reading the status from the PLC in the server. Okay, now how do I get this value in my factory IO? That was the question. Okay, now we know that KepServer is defined, so I will just minimize that. This is my KepServer. Now I will open factory IO. So here in the driver, if you are using factory IO, it's one of the greatest software I know for simulation, to simulate your Logix, right? So you go here, click on OPC client data access, because we are accessing the data. Then you go to configuration, because you have to define which OPC you are using. So if you see your OPC server, and if your OPC is working fine, you will see KepServer, KepServer. Browse item means how many items you want to browse in your tag, in your window. So 32 is fine because we just want to read M0. Now, if I click from device and browse item, and I go back, you will see a lot of tags here. Now, most of these tags we don't want. And why do we have these tags? Because if you go here, client, you have a lot of tags here. Okay, maybe we don't want them. So what you can do is you can either delete these tags. I'm going to delete this one to see if it works. So this PLC has M0. I go back here and I go back to configuration, click browse item again. I go back, but it's still here. So how to get away from that? You go to configuration. In the filter, I will write DVP12SE because this is what I wrote in my tag M0. So it will filter out all the tags which are having this name. So now I have just M0, right? We see our tag is here M0. Now let's take an example here. So what I'll do is I will take a small conveyor. Let's say this 2-meter conveyor, right? And I go to the drivers. Now this conveyor I connect to M0. Oh, here this conveyor is connected to M0. Now this is conveyor, this is the conveyor here, and that's my PLC here. So what happens if I set M0? You can see the conveyor is running here. Let me just short this window, minimize this window. Pretty nice. And if you hear some noise of baby crying, my owner baby might be crying. Baby cries all the time. So yes, here you can minimize that. This was M0, and this is linked via OPC server to our factory IO. And if you see the drivers, this M0 bit is green. Set off, this is off because this is M0, it's reading and writing the M0. So that's how it connects my conveyor and it's running. So this was the example how you can link a PLC with a software and with a factory IO together in case of Delta PLC. All right, now I'm going to make a small logic here, but to make a logic I have to add a lot of tags here. Okay, so what I'll do is I have a small shortcut. What you can do is just open your client, not this one, just cancel it. Here, this is your tag table, right? Click on Delta PLC and click export CSV file. So you can export CSV file. Let's name it Delta 12P PLC 12SE and save. So I saved my Excel sheet with this address, and I will just go to my desktop, check where it is downloaded here. So this is the Excel sheet I got, and this is the tag list. Okay, now what I have to do is I will just select this one. I can use maybe 15 memory bits or 10 is okay, or let's take 15. Just drag it. So now you have 15 tags, but please note that here it should be 0029, but because this is Excel, we will change it later. Respect data, it should be same, 111. Scan rate should be same. Scan rate is the time which it takes from PLC to read it. Okay, so let it be 100. So what we can do is this is saved. Now we need outputs as well. So for output, the address was 1281. So here what we can do is we can just extend it here, and I will write here Y0. Okay, and here extend it to 15. Now the address of Y0 starts from, if you see the table, 1281. So it should be 1281, and then extend it should be 1, and this is 0. That's okay. 100. So these are my output addresses. Now what we'll do is we will upload this to our KepServer, so we will have all the tags. Okay, so I'm going to save it, the same name, Delta 12SE. This is a shortcut, otherwise you have to write each and every tag here. So let's try if it works. It should work. I will delete this one, and I will do import. Now when I import this file, sharing violation exists. Wait a second, let me close this one. Now import. All right, so we have all the tags, but these tags has some error because the address was 00. So quite annoying. I have to change it because in Excel, I think we can do it in Excel, but I don't know much about how we can have 00 in the Excel before. If you know, it would be more easy, and you can also comment that how to do it. I'm not sure about it. So this is just a small homework I have to do all the time. But I hope there should be some way. Let's apply, okay, and apply, okay. So this was the basic of how you can link your PLC with KepServer, and it's not only Delta PLC, you can link any PLC you want. You just need to know the communication parameters of PLC. If it is Ethernet, you just need to know the IP address. If it is not Ethernet, if it is serial port or any other PLC with USB, you just need to know its communication parameters. For example, parity, baud rate, and stop data, start bit, data length. That's all you need. Then you can link any PLC with your KepServer. I really find this software very amazing to work with. And I will just look at your comments now. Hold on, just let me change all these, and then we will proceed with the logic. Apply, okay. Apply, okay. Oh, that's very annoying. I should not use this Y0. Generally, after Y7, it reads 520 because it works in octal system. So over to your comments. Thank you. How can you give a lesson on ETAP? Mr. Nadeem, what is ETAP? I don't know. Okay, hi, hello, we can hear. Can you do a PLC from Siemens? We already have a lot of tutorial on Siemens, Mr. Vinay. You can check my channel, and if you will find some few demo videos. If you want more videos, you can join the course where you will see all the Siemens video tutorials. Tutorial series for beginner, Harmandeep Singh. Harmandeep, you can check my channel on Learn PLC in Hindi, and they have all the tutorials in Hindi. All right. Thank you, Muhammad Adif. Thank you for your comment. All right. So tags are defined, and let's go back here. Go to driver and configuration. Just click browse items, and you will see all your tags. Very nice. So this is so cool. Okay, so let's go to our Delta PLC and make a logic. Now we are making a very basic logic since we are starting this live session, and I will make a very, very basic logic. So let's talk about, let me extend it here, a conveyor with start stop control. Okay, so I would like to replace this conveyor. It's quite small. Let's take a bigger conveyor. 4 meter is fine. It's perfectly fine. Now I will take some sensors and some buttons. So let's take a panel first. Everything starts with a panel. Now if you don't know how to wire the panel, wire the buttons with PLC, hopefully I can do one more lessons on wiring the PLC. And okay, some questions. I'll get back to you. I'm going to get a software license for Automation Studio's education version, and maybe I can use it for wiring, for teaching how to wire it for hydraulic pneumatic lessons. I'm not sure if that license will allow me, but I will see. If you need to know the wiring, I can use that software for wiring. Okay, coming back to your questions. Electrical Transient Analysis Program, ETAP. Mohammed, I'm sorry, this is not my area. That's not my expert area. I cannot make tutorials. Maybe someone else will. Hey Rajveer, I connected right now. Will it be available on Udemy? Yes, Jonas, this will be available on Udemy. If you're talking about this lecture, this is on this is on YouTube. This will not be on Udemy, but this is an open discussion channel which will be on YouTube. All right. Oh, thank you. So let's begin. We have a panel here. Now we need some switches. So I will take one start switch, which is a very common type. Oh, where is my start switch? Oh, there you are. Silly guy. Come here. Come here. I want to put you here. Very nice. Okay, so we have start button. What do we need next? We need a stop button to stop the conveyor. Come. And you can be here. This is my stop button. Now, the most important button is the emergency. You should be here. Okay. Now we need indications. For that, we'll take a tower light. Tower light. Come here, or I can put you above. Oh, is it okay? No, it's not okay. Here. Just, oh, very nice. So we have start, stop, and let's take one more, a reset button. To reset the errors, just in case we have some errors, we have reset button connected here. You know, this is a very nice software to work with. You can immediately link your environment with your PLC logics. So we have emergency, start, stop, reset. Now what do we need? I think this is okay as of now. All right. So let's go to drivers and link our inputs and outputs. So we have start button. I will link it to M0. Okay. Stop button. I will link it to M1. This is M1. And emergency we can link to M2. Okay. So start. You can see stop and emergency both are true. This is more green than the other one because these are NC. I hope you know that. Okay. Now what we have in the inputs, we have nothing. We have the outputs. On outputs we have belt conveyor. This can be Y0. Y0 is my conveyor. And what do we have? Light. We don't need one. We need these stack lights. Okay, what I'll do is I will click this, connect this to Y4. So conveyor is Y4. I will put lights. Y3 is better. I'll put lights here. So red light is Y0. Yellow light is Y1. And green light is here, Y2. So we have these outputs, 4 outputs and 3 inputs. So we will just run the conveyor and make some indications. Okay, so go back. So coming back to PLC. Now in PLC, if you have seen my old Delta tutorials, I was using the software. Okay, let me delete this. I was using the software WPL Soft. So ISP Soft I have used in my Hindi tutorials, but I would like to extend this ISP Soft software in this channel because this is an open source software. You can also download it. You can also simulate your logic in it. And I'm going to use some functions here. So let's define the functions and then we'll work on this conveyor. So I will go to function and this is my function builder window here. Just make it bigger. Now, what do we need? We need a start button, stop button, and reset button to play around with the indications. And then we have this conveyor. So what I'll do is I will press start to latch the conveyor. So I will just take LD start. Okay. I'll put start. This is my variable and variable is an input because start is my input. Start input. This is Boolean. Click OK. That's my start. And how do I link the start to this button? I will come back to that later. Start button is going to set my conveyor. So I will write set conveyor 1, con 1. I'm writing con 1 as a conveyor 1. Okay. This is an output. So I'll take variable output. So that's my output and that's my input. So start is going to set the conveyor and I prefer to use rising edge. That is used to trigger the conveyor. And stop button is used to stop the conveyor. So I will just go here and click another network. That's how you get a new network. And now you will use stop button is NC. So you will use LDF stop. Oh, It says stop is a reserved word, so I cannot use it. So I've used stop NC. Stop NC, variable input, click OK. Stop button is going to reset my conveyor. So reset, just use reset, and then you can select what do you want to reset? Con1. So you can reset conveyor 1. Okay, now this was the start stop of conveyor. Now we can also display something here. So if conveyor is running, I will display green light. If conveyor is stop, I will display maybe red light. And if emergency is pressed, maybe we can display some other light. Okay, so let's just play around with green and red. So that's very easy. You take another network and write it, press enter when conveyor is on. So click conveyor is on. You need a green light. Just write out, and then here you write green. Okay, green is your output. Select output, click OK. Very easy. Just go down. Now when conveyor is off, you need a red light. So LTI is conveyor off. You need a red light. Select out, and here select, just write red, and this is your variable output. Click OK. So perfect. This is red, this is green, this is our function block. So let's just try that. Go to your main logic. Now this is the function block which we have made here. You can rename that to conveyor. This is okay, conveyor 1. Oh, that's fine. Go to main logic. Now drag this here, maybe to the network 1 conveyor, and it will name your function block. Conveyor UI is fine. Network 2 we don't need. Now we have to mention our addresses which we have defined here. So stop NC was M1, so M1, enter. Start was M0, enter. Red was here, Y0, so just write Y0. You see how easy it is to write addressing now because we have defined the functions. And green was Y2, and conveyor 1 was Y3. That's it. So let's download this logic. I will come back to comments later. Stay tuned, and just let's download this logic. Some error. Let's see, what is that? What is this type? Symbol type does not exist. Which one? Indication UI. Why it is there? All right, once again, now it's fine. I'm going to download this logic in my PLC. So if you can see my PLC, it's just getting out of the camera. You can actually see the status of PLC. This is running now. So I don't know if you can see the lights here. If my visor is on, you will see the indications on my PLC. Okay, so go online. So everything is okay, and you can see here all the 3 lights are on. And why they are on, let me see that. Drivers Y0, Y1, Y2. Y0. Wait, let me download the logic again. Transfer, okay. Go online. This is quite strange. Let me check what's going on. Something wrong with the server, I guess. My PLC says only Y0, Y1 and Y2. We haven't used any Y1 and Y2 here. Let me check the status. Where is the monitor table? Y0. Sorry. Y0 is on, which is red, which is okay. Y1 is off, and Y2 is on. That's fine. So PLC is okay. Something wrong with the KepServer. So Y0, oh my goodness. That's my mistake here. so sorry. I did not took care of these addresses. This should not be same. It should be in sequence. Y4. 4? Was it okay? Oh, this should be 5. You have to be very careful when you define the addresses. Otherwise, blunder will happen. This will be 6. This will be 7. And this will be 8. And I will not take the addresses more because this doesn't make sense anyways. So I will delete these tags. Yes. So up to Y7. Okay. So sorry, my mistake. So I will just go here and click browse item again. Oh, it erases everything. All right, no problem. Just go to main. Stop was M1. So stop button was M1. Start button was M0. Reset was M2. Emergency was M3, I hope. And belt conveyor was Y3. Y3 here. Red light Y0. Oh, reset. No, not reset. Stack light red, green, and yellow. Now it's fine. So that was wrong, my mistake. So you can see here, initially belt is stop, red light is on because our logic says that here. Okay, your belt conveyor is stop, so this bit is true, and logic red, this red is on, and this red is linked to our main program to Y0. So when I press start, this changes to green and my conveyor is running. All right, very easy. So when I press stop again, my conveyor stops and red light is on. With start, conveyor is running and green light is on. Okay, now we have to include a logic of emergency. If I click emergency, then red light should blink. In case of emergency, red light should blink, and if I release the emergency, I should press the reset button to reset the emergency state. Then everything should happen. How do we do that? So I will go to the comments now. Okay. Hello sir, I hope for Siemens you too how to link Siemens PLC to Factory IO. Abu Aisha, the Siemens link, if Siemens PLC, if you have Ethernet version, in Ethernet based Siemens PLC, you just link your IP address in your Factory IO, and it's quite easy because in Factory IO you have S7300, S7400, 1200, 1500. So if you have Ethernet based PLC in Siemens, just put it IP address and this can be linked. If you're unable to link it, just write me a comment in the video, put your email ID, I will send you some documentation. All right. And second comment, Vinay Jamwal sir, anything about MES? MES, actually I'm working on a project in which I have to execute a SCADA interface with MES. So it's quite complicated, but I will be most probably doing it with Ignition SCADA, and we have a big station with 2 robots and a lot of PLCs and HMI, and we have some cameras, we have RFIDs. So we will be executing MES in that, and I have a friend who's a programmer from last 30 years. We both have decided to make a course on that. So probably it will take some time, about 3 months, but we will launch a course on Industry 4.0 in which we will execute the base level automation, then SCADA, then MES. So these whole levels will be covered. And hello sir, when you start with IoT industry? Kanav Rajput, I think I just answered your question. Industry 4.0, we are working on a project of Industry 4.0. And we have planned to make a course on it. So I can't make it alone. It's a big project. I'm working with some German engineers. So I have a German friend with whom I will be making this course hopefully in 3-4 months. So let's see. Do you have any topic related to creating and calling subroutine in PLC, and tell me the use of calling subroutine instead of main program? Vamshi Krishna. Well, in subroutine, I have some video tutorials, but it's not on YouTube. It's in my course. So if you go to the course Learn 5 PLC in a Day, you will find there some subroutine programs. It's more like calling a function block. If you make a function block like C, I've made a function block here, I'm calling that in main program. It's more like that, because you make a subroutine and you just call it in the main program. Use blinking bit for blinking. Yeah, of course I will use it, Mohammed. It's not M1003, it's M1013. Sir, my PLC is Siemens S7300. My email ID is this. All right, great. I hope this email ID stays in my comment. And for PLC S7300, it's 2DP. I hope I will send you some tutorials, some documentation where you can link that. All right, so let's proceed. So we need to include emergency stop. So how do we do that? If you know already, you can comment, otherwise, and we need to blink red. So I have to make sure I make a logic in this red network. So what I will do is I will click the contact and we can put in the panel. So if emergency is pressed, so I will write here emergency, EMR. Okay, wait. With emergency, we will take a bit first. Okay, so I will write LDI. Now I'm using emergency NC because my emergency is NC outside. Okay, and I want this emergency. Okay, let's take falling edge to set a bit. Set what should I put? Fault. Let's say emergency. It's not a fault, but let's see what we can do it. Let it be a variable. Okay, now emergency will actuate a fault bit. Oh well, I have an idea. In this Delta PLC we have a bit which is M1034, and I can use that bit. So I will rename this to disable or disable output. There's a bit in Delta PLC which disables all the output. Okay, so I can use that bit. So in this disable output, I will take variable output. So we will disable all the outputs when emergency is pressed. So we will set that bit. And when this bit is set, we will use this bit here when outputs are disabled, when this bit is set, and we will take a blinking bit, which Mohammed said. So we'll take a blinking bit, which is M10, or I just write here blinking bit, because I will just take variables. Blinking bit comes, where is that? Oh, why it's blink? Blinking is variable input. Yeah, blinking bit. So when I press the emergency, output will be disabled and there will be a bit which will give it to red. Now here there will be one problem. I think if we disable the outputs, you cannot actuate the red. Okay. So what we do is we just write with emergency. Okay, in this example we are just dealing with the conveyors, so we will just reset the conveyor. Okay, that will be much easy. So with emergency, what I'm going to do is, first of all, I'm going to reset the conveyor. So here it will be conveyor 1, con 1, and we will take another bit which we need to reset. Okay, so I will take it in parallel. I will set emergency bit. This is a variable. Now if emergency bit is set, this will put an interlock to all your outputs. Okay, so when you press the emergency, first of all, relay will be reset, and second of all, this emergency bit is going to interlock. So if I press start after pressing emergency, nothing will happen. So what I'll do is I will put this here, take NC, and I will use emergency bit. So when emergency bit is high with my emergency, this letter will not work. Similarly for stop is okay, and conveyor is reset. That's okay. So we will take here emergency bit now. Okay, and this will blink the red output. Okay, so let's check that. I'll go to main. So this is again updated. So blinking bit is M1013, and we don't need disable output. So let me remove this from here. All right, that's it. We put a blinking bit here and define the logic. Let's download. All right, one more thing is left. How to reset the emergency. So to reset the emergency, we have to reset the emergency bit. So I will take one more network. Now here I use the contact reset, and this is going to reset my emergency bit. So here I'll write reset. Reset is my reset button, so I will take variable input, and this is going to reset emergency bit. Emergency bit is just a variable. If you see here, I'm not using any input output, it's just a variable. And this disable we don't need, and this emergency we don't need, fault we don't need. I used it before, so that's why it was there. All right, go back to main and reset. Now what is my reset here? My reset is this one, M2, put M2, enter. That's it. So download the logic, go online. Oh, some error. Let's see what is the error. Emergency, we are not out. Okay, this was emergency, sorry. I totally forgot. This was my variable input. Emergency is variable input. Now it looks okay. Emergency is here. Emergency stop M3. M3. Let's see. Now no errors. Download. Transfer. Okay. Okay. Close. Online. All right. So again, process is stop. No problem. Let's start it. Conveyor is running. Green is on. Stop. Red is on. Conveyor is running. Now I press emergency. You can see this emergency has stopped the conveyor, and why it's not blinking. Let's see that. Conveyor is stopped. Oh, okay. We should put some interlock here, because this conveyor NC also giving a signal. So you put here NC of emergency bit. All right. So I will put here NC. This will be emergency bit. Now everything is okay. Download. Okay. Okay. Again, reset, start. This is stop, and start again. Emergency. Now you see this is blinking. And sometimes when red light blink in any factory, user or maintenance people immediately get a signal that there is some error. Sometimes we also don't use red color for stop. Depends upon how you are configuring your input and outputs and how you're displaying the LEDs. So this red LED means, okay, there is some problem. Let's go and check out. So if you release the emergency, it will still blink. And this is still blinking because we are using emergency bit in this case. Let me show you. You see, this is blinking because of emergency bit, which was set by emergency switch. So this bit is a variable, the switch is my button here. So if you want to see how this is working together, I can show you again from here. So this will get reset by a reset switch. This will reset my emergency bit and blinking will stop. And because emergency bit is true, I cannot start my conveyor. You see here, I cannot do it. I'm pressing the button. This is getting green, but conveyor is not set. So I will click on reset. When I press reset, emergency bit is off. Everything is okay. This is red because conveyor is stop. So again, start, conveyor is running, and I press stop, conveyor is stop. Start, conveyor is running, emergency, conveyor stops, red blinks. And if emergency is pressed, you can also do one thing. If emergency is pressed, if user did not release the emergency, this bit should not be reset. Okay, in that case I will take its NC, because now if I press reset, it will reset, which should not be the case. So I can even optimize this logic, and I'll take NC here. Okay, now you will see you cannot reset unless your emergency button is released. So this is emergency is pressed, I cannot reset. Okay, you can see that I press, it will still blink. So when I release it, then I can reset it. So again, start, this is stop, this is emergency, and release emergency, reset. So this was the second part of today's logic. Do you have any questions? If you have any questions, you can put me a comment. Otherwise, we'll proceed. Now, let's play with some sensors here. So what I want is, I want to put an emitter here, which will give me some box, and I will use a sensor to start the box on the conveyor, and I will use another sensor to reset the conveyor. Okay, so let's go here first and stop it, and let me stop my PLC. By the way, if you can see my PLC, you can see some button status here. This is running inside the PLC. Just want to show you that your PLC is actually working, and this is linked to my software. Okay, now coming back here and make an input. So in this factory IO, you have an emitter, this arrow, this will give you a box. So I would like to place this emitter on the conveyor somewhere, maybe here. Okay, I can put it here. Or if you can't see it, I would like to change the location of this panel, and would like to make a group first. Make it a group. By making it a group, it's easy to change its location. Okay, that's fine here. So we have this emitter here. Now with emitter, we need to have a sensor which will start the conveyor as soon as we have a box. So I will take one diffuse sensor and connect it like this, and I need some metal cover here to give it some support. This is okay. Connect it like this, and I need to rotate the sensor. Very nice. So, or we can just align the sensor in the center. Okay, so this sensor is going to start my conveyor, and I want to stop the conveyor when I have another sensor here. So what I'll do is, I will right click these two guys, make it a duplicate and put it here. Okay, so this is how you have two sensors now. All right, so let's have a box here. Now what box you need, you can just right click this guy and select the box, which box or which part you need here. So let's not take the pallet, let's just take one box, which should be, no, we can take a medium box, right? And time to, no, that's fine, we just need a medium box. So now to get the medium box, we have to trigger this emitter. So if you see the outputs, this emitter is already blue, which means it is force. So you should release the force, because we are going to emit the box using a PLC output. Okay, so this was emitter, and if you see the PLC diffuse sensor 1 and diffuse sensor 2. Okay, so let's go to the logic. Now what we need, when we press the start button, we can trigger this emitter. Okay, so our start button, where is that? Start button is here, and we can take in the paddle of conveyor, I can take like this, I can trigger the emitter. So I will write emitter, emit, just emit, and variable output. Okay, with start I'm setting the conveyor, I'm also triggering the box. So box will be on the conveyor, but in this case now conveyor will not start with start, because we have to start conveyor when you have the sensor signal, not with conveyor. So I will delete this conveyor, because conveyor is going to start with my sensor, diffuse sensor 1. So I will go down and make another network, and I will write LDP. LDP is my rising edge of what? Diffuse sensor 1. So I will write DS1, first sensor, and it's my variable input. So we take variable input of my first sensor, and whenever the sensor gets the signal from the box, conveyor will start. So here set, just set, and here you will set, where is the conveyor? Conveyor variable was con1, should actually show con1, it's range, conveyor 1. Okay, now conveyor is started, and again, just to interlock it, we will interlock this with emergency bit. So we will take emergency bit here in the NC. This is interlocked. Conveyor will start with the sensor, and conveyor will stop with the rising edge of diffuse sensor 2, or you can say the falling edge. Let's take the falling edge because we will be extending this project in the next live session. I'll be using more conveyors. So I will use my alarm, strange. So this is my falling edge. Okay, so when the box passes the sensor, when the box passes the sensor range, it will be stopped. Conveyor will stop. So I will use its falling edge. So I can actually use this button here and press this parallel insert MPS here, and falling edge. So here it should be LD falling edge DS2 second sensor. DS2 is my variable input, and conveyor stop. So con1 should be reset. It's reset. Okay, that's it. Sensor 1 starts the conveyor, sensor 2 stops the conveyor. Everything is okay, everybody's happy. So go back to your main logic. Now you have to define the sensors. This block is getting bigger. I like working with function blocks because it looks nice. So sensor we can take at M4 and M5. So diffuse sensor 1 is at M4, diffuse sensor 2 is at M5. So sensor 1 DS1 is at M4, sensor DS2 is at M5. That's it. Let's go back and check the logic. Download, transfer. All right. I will come back to questions. Wait a second. I will come back to your chat. Just check this logic. So red light is on. This is okay. Everything looks good. So I have to press start to emit the box. I press start. Okay, I did not use the emitter yet. Wait a second. My mistake. The emitter, where is the emitter? Here. Emitter we can use at Y4. No problem. Y4. Download, transfer. Okay. Everything looks okay. Close, online. Yeah. So going back, pressing start, emit the box, sensor starts the box, and the other sensor stops the conveyor. Again, a box comes because of the sensor signal, and it gets stopped. So we have to do one more thing we forgot. Our emitter should not give continuous boxes by its own. Okay, we have set the emitter, but we have not reset the emitter. This is not reset anywhere. So we can reset it with the falling edge of the sensor. This sensor can reset the conveyor or reset the emitter. Okay, so reset the emitter. We can go offline and take another network. I prefer to take here, click like this, and then you type LDF. Actually, I prefer to take it from here. LDF of diffuse sensor 1, DS1, right? And this is going to reset my emitter. Reset, emit. So that we don't have so many boxes. The boxes will come when I press start. So start is actually emitting my boxes. Download. Everything looks okay. Okay. And yes, very nice. Go here online, reset everything. This is start. So start will get my box and reset here. Everything is okay. I can take away this box and we can start again. Start will get my box. Sensor will start the conveyor. This sensor will reset the conveyor. All right. If you want to see this continuous operation, let's do one thing. This will be very interesting. Let's align the sensor bit here. and I will put a remover here. Okay, so when I put a remover, the box will be gone and I will not create mess. So let's take a remover, put it here somewhere. That looks nice. Not so nice, so maybe a little bit more. This guy comes here, or let's do one thing. Let's put it down so that we can have more area to see what's happening. Put the sensor here. Okay, so this remover, I would prefer to make it forced. So this is already forced, so that we don't have to activate the remover. And now if you want to get automatic next box, when this box falls down, we will use the falling edge of this sensor to again emit instead of pressing the start button. That would be more automatic operation. So emit here is there, so you need to have a parallel bit here. Go offline, take another bit. This is very nice. Falling edge of what? DS2. That's it. So falling edge of this sensor will bring another box. Okay, so just download this logic to see what's going on. Download it, close online, run. Okay, so now it's red light, press start, box comes, and the box will go down. And again a box comes and it will go down. So this is a kind of automatic operation. All right, so coming back to your questions now. Hello sir, thanks. Okay, have you removed the first session held today? Yes, I have removed that session because that session was quite messed up. So I will be continuing this session and making it in a very sequential way. Oh, I can see my sensor isn't flying, so okay, we'll fix it. Second question, it was inaudible. Vinay, what was inaudible? Can you hear me now? Brother, what's the name of this 3D software? This 3D software is Factory IO. And if you want this software, you can download the software from our website for 30 days trial version. If you want to purchase it, you can purchase from our website. We have some starter license, we have Siemens license, so you can check that one. Compatibility with RSLogix 5000. Yes, it is compatible with RSLogix 5000. If you go to the driver, I can show you actually. If you go to the driver, you can see RSLogix 5000. It is compatible. Okay. Good to see a person behind this amazing video. Thank you so much, Ranid. Good to see this comment as well. Any plans to update your Siemens 1200 course on Udemy? Marius, I have updated the course recently, and the update was on Siemens alarms. So if you check the video, there are 3 videos in the end of the lecture about alarms. So that's a small update, and in the future updates, maybe I will link that Siemens PLC with KepServer, or I will also show how to link this PLC with SCADA software. And if you have more suggestions, you can write me. And one more update, it's about to link Siemens PLC with encoders. I have one encoder here, and I can show you how to read high-speed encoders. Please bro, this software free download link. Sajid, you can find the software link in our website. If you don't know, I can show you here. We have NFI website. Oops, I clicked it. And you can download this 3D software, the trial version, and if you want to purchase, you can also purchase it. So we go to website NFI automation, and then you go to offers, and in the offers you will find some links. Go to software licenses, and in software licenses, these are the Siemens edition license, and this is a starter edition. Click on that, and you will find a 30 days trial version here. So when you click here, you will have this website, and here you can download the trial. Okay, so that's how you can download. But if you want to purchase this software, starter edition is $118, and this is for lifetime. but this will not have OPC server. There are several different modules. This will have only Control IO module. Control IO is one of the driver in the Siemens or in the factory IO by which you can simulate these simulations, but you cannot link the PLC. To link the PLC, you can either have Siemens modules here, or the one which I'm using is the ultimate version, where you can use this ultimate edition. This is not in the website, but if you want, this is quite a little bit expensive, but you can link all the PLCs in this driver. What was the next question? Also would love to video explaining automation hardware like sensors and switches. Hello Marius, hello again. Well, in the end of this month, I will be getting an IO link of a company IFM, with which there is a distance sensor. So I'll be showing, and that sensor can be worked in two ways. One way is you can display whether the object is present or not in that sensor. That's the one way. The second way is you can find out how far is this object from the sensor, and that's very interesting. And you can read this sensor using an IP address because it's an IO link. You can have a dedicated IP address and you can link that with your sensor. This is called IO link, and it's a new technology. So hopefully by the end of this month, I will get this kit and I will be making a video on that so you can see how it will work. So these were your questions, and I hope this live session was good enough. This was just a small introduction how to link the PLC with KepServer, which is running here. And if you want to see the data in the KepServer, this is the data. This is being updated, and because of this data, you can see here once again live, this information is actually going to KepServer, and then it's going here. So everything is linked here. Oh, where should I place it? Not much space. Let's put it here so that I can show you how the interface is going on. So these are my tags. Wait a second, data type. Yes, these are my bits. These are this is the PLC Delta 12 SE. That's the hardware here. So this PLC is running via this software. This software is sending signal to my KepServer. Here bits, you can see the bit status 10. This is being changed here like M5, and you can see the changes in these outputs. All right, and this information is going to factory IO. So that's how it is linked from PLC to KepServer to factory IO. So if you have a KepServer, you can also link other 3D third-party technologies with KepServer. You can design your interface, you can make some buttons, and you can execute it, since you can also design an HMI. All right. So thank you for watching, and if you're new in this channel, just go and subscribe so that you can watch a next lesson, which we will continue. I plan to extend this lesson. In the next live session, we will have one more conveyor going here, and then we will put a vision sensor which will sense the ID of the box, and based on the ID we will sort the boxes using a robotic arm, something like that. That's what I plan. So thank you for watching. If you have anything else, you can put me a comment. And is there any course on code assist and universal robot? There will be a course, but it will take time because I have to first utilize this Delta PLC to show some examples. And my next lesson would be on next sessions, maybe in 2 months, will be on code assist and probably on universal robots, because currently I'm working on these universal robots. I have to study it more to deliver some content, and my life is pretty busy. And yeah, so thank you for watching, and I hope you will join me in the next session and have fun. See you next time. Bye.